Hello everyone, Assalamu alaikum. Today we will go with this example, number 11. It's a new example. Um, this example state run a module from IDE and manually examine or debug, actually, an asynchronous communication using KAFKA. As we all know, in microservice environment or architecture, there are multiple ways to communicate between services, but we can categorize them into categorization. Synchronous communication like HTTP request or gRPC or RPC in general requests, or synchronous communication like message brokers. Okay, for example, here we are using KAFKA. And in our example, why we did example for this one, because in some scenarios the communication between the service the two services you are debugging is synchronous communication, not synchronous communication, the usual one we all know. Okay, so today we took an example, the communication between mode inventory storage and mode search while handling instance, like creating an instance. And in this case, after the creation in mode inventory storage, an event will be produced, okay, and mode search will consume that event message and create the same record in the Elasticsearch index for the instances, okay, to be synced with the real database. Okay, so in the real scenarios, in your own scenarios, it may not be the communication between these two modules. Maybe you will have another two modules communicating through asynchronous communication using KAFKA. So the example may be not exactly what you encounter yourself, but we will showcase the communication, how to debug an event or asynchronous communication. When I produce an event, how I can debug this scenario. Okay, let's start working. Before going anywhere else, I managed to run the script behind the scenes. Okay, I added mode search module to the sample modules. For this, I also added a new permission for mode search. Okay, and everything is up and running right now. Let's see how it works. Before we go there to Postman, let's have a look here. I am now listening on any event sent for or produced to this topic, which is our topic, folio, test, the tenant name we use, inventory, mode inventory storage, the module, instance, the record itself which we are creating. Okay, we're utilizing this bash script, Kafka console consumer. We bootstrapping on the server, and we listening on this topic with this name, on the topic with this name. Okay, let's go here. First, we should log in with our credentials, and we can now add, let's go there. Oh, here's our payload. This is our new instance with this title, resource title Zaki. Let's add it. For this, I will clear my old test and send a new one. As you see, we created a new instance, and this instance has been created in my mode inventory storage. So if this is a mode inventory storage GET request to return instances with the query resource title Zaki, title equal resource title Zaki. Let's have a look. If we take our ID from here, we should find it here as well. Fine, it has been created in mod inventory storage. It should be also found in the Elasticsearch. So we have another GET request to list the instances from Elasticsearch with the same query, or you can say it's somehow exactly, somehow nearly like the other query. It will show us the instances that has title with this value, resource title Zaki. Let's hit the endpoint first. As you see, the total records has been incremented and our title exists here. Let's have a look here. As you see, we have our payload, our value, our event message value. It has been printed out in the console. We can manipulate the options here to see more information, detailed information like the key and so on. But we are sufficient with this result. This is only the showcase to see that the event has been actually produced and also consumed from mode search. What we want to do, we want to now to debug this communication. What we saw now is the module works fine, no problem, okay, but we want to debug that process itself. Okay, so firstly we should stop mode search and mode inventory storage, both of them. Mode inventory storage, we will stop it for another reason. Okay, we will start with mode inventory storage first. Why we want to stop mode inventory storage? Because we want to get the information we need to produce the event manually, to produce the Kafka event on that topic manually, without the need the automatic without the need to let mode inventory storage itself to produce the event. We want to produce the event ourselves. So we will first stop mode inventory storage from where we did know that it's 32. Actually, you can simply go up here. Our mode inventory storage is 9132. Okay, and we can also go to the deployment API, tenant API, internal API request for Okapi, and you'll get all deployed modules, including our own module mode inventory storage, and you will find the port number there. Okay, let's stop it. Let's have a look at our configuration, which has been configured behind the scenes. I have my main class, REST launcher, and my argument to start the vertical. Okay, and here we have our environment variables. We have the database configuration, Kafka configuration, and our options, JDK Java options, port 9132 on the port, and HTTP port, the same port. Okay, everything is fine. Let's start debug. Picked up the environment variable, started very good without any problems, adding all routes, listening on the port we specified, very good. Okay, let's start digging in. We will first look up the API class which handles the add request. We will type here instance storage API. I did it behind the scenes, so I know where I should search. Here we have our method, control method, which handles the creating instance request, and we'll go in the create instance inside the service, and after everything succeed, we will find our publishing event, domain event, publisher, publish, created. Let's go there. Here we will start the process. We will go to publish record created. Let's go there and publish records. And see, we are moving to another class instead another class, and so on until we reach our destination. Publish record created. Let's go there. Publish. I think we are reach our goal. Here we actually send the event, okay, on that topic. What we want to do, we want to know the information we need. We need to construct our own event and produce the events manually, okay. What we need is the key, the value, and the headers. These are the three important values we actually need to construct our own Kafka event message to produce it, okay. Now as we run in debug mode and we edit our breakpoint, let's hit the endpoint again, okay. Wait a little bit. Very good. We reached our breakpoint. As we see here, we have our information. It's actually coming in the parameters for that method. We have topic, key, and value. Everything we need, except the headers, but we actually can get it here. You will see here. You see here that these are the headers we need. Okay. If we go to the topic, up here, folio test inventory instance, the same key we listened on in our console, as you see here, okay. And we have our key, which actually is the IDE itself. Now we have our value, which is the payload. If we see here, new entity, here are old and new. In case of update, we have all our instance information. All the information we need exists here, okay. So what else? Actually, what we aim for, go there. We have the value in the JSON format. This actually what we need. After everything finished here, they will convert the value to a JSON format to be sent to Kafka, okay. So we need this value, okay. We need to have this value, and we need also to have the key, the topic, also, and the headers. We have here this value, the tenant ID, test, XOCAPI token, XOCAPI URL, XOCAPI tenant, XOCAPI user ID, and XOCAPI request ID. Okay, we can add these or copy these information outside and use it later. Actually, I did copy all this information myself earlier, so we'll not do it here. But you can know, from where you can get the information you need. If you go to mode search, we have another breakpoint here where we listen from the other side of the communication, and we have the Kafka producer plugin. Okay, the Kafka plugin. We can construct our event here, as you see. I searched for our topic and picked it up, and I added my key, which is an ID, UUID for that instance, and I added my own value as a string. You can edit also here as JSON, no problem. And I added my headers as well. Okay, You can do it yourself, like we saw here. You can gather your information from here and go there and edit these and add these information and produce your own events. Okay, I simply continued. Can now do this. If you go here, you will find a new event message has been produced. But let's do it ourselves. Let's firstly start mod search from the terminal, from the IDE, I mean, sorry. Let's stop mod search. It's operating on port 41. Again, you will find it here. If you go down there, a little bit up, mod search operates on 41. Okay, mod search operates on 41. So we will stop the module and we will start it from here. Before we start, let's have a look at the configuration. We have our Elasticsearch in Java JDK options for our port, KAFKA OCAP URL. This is very important. It will not work without this environment variable. You should have the OCAP URL present here. And we have our Spring database configuration, as we use mod search, which is a Spring application. And we have the system user name and password. We can also have the enabled environment variable, and put the value true, which is actually the default value. Actually, if you go here and have a look at the modules, I actually did manage to edit here. It's the same. Let's go back, and everything is fine to go. Let's start the module in a debug mode, of course, so we can use the breakpoint. Let's wait for the module to spin up. Now we are almost done for our example. Take a little bit to start for some reason, but it's not our concern. The main thing is it should start fine. That's the whole point, and it started very good. Now we can start produce events. Okay, we have everything fine. The topic has been selected, and the key has been pasted here, put here, and the value exists also, and the headers. Let's produce our event. Very nice. As you see, we did manage to debug our asynchronous communication. It's very simple, actually, but we started from the beginning, so it took some time to explain everything. But actually, if you know it and you did it once, if you want to do it again, it will not take that much time. We'll only inspect where the message has been produced from the mod inventory storage, as we did earlier, and you will gather all information, key, the topic name, key, value, headers. Copy this information, go to your plugin or the KAFKA plugin here in the IDE, IntelliJ, or any other tool, and construct your topic create a topic, and if it's not created yet, or create or use it if it's already created, and construct your own event message and produce that event, and listen and add your breakpoint on the other module, where the module which listen the consumer module, okay, which listens on this topic, and you are good to go. Now we can simply continue. Yes, this is here actually. We managed to go to the finish line very early, as you see here. You can put it here to make it. You can simply like this. Yes. Okay, I think we are finished for our example. What we have learned today is how to debug asynchronous communication using Kafka in our example here, and we used mod inventory storage and mod search as an example. And this communication happens a lot in Folio environment, in the OKP microservice environment, and in some cases you will encounter the communication between two modules along the process is synchronous communication, and you want to debug that communication only, not the complete process. So in that case, if you struggle with it, you can simply construct your own event message and produce it by yourself, and from the other side you can listen, add your breakpoint on the consumer module, and start debugging as we saw here. Okay, thank you, and see you in the next one.